Okay, today we're going to talk about converting um, uh, equations into standard form for circles. Circles are pretty easy, but ellipses and hyperbolas. And they kind of follow the same idea of completing the square, which you have learned about completing the square at some point before. We're going to start with a kind of easy one. So I know because it's a minus on the y squared, this is going to be an ellipse. And these are supposed to equal 1. So I'm going to divide both sides by 36. And I get 4 over 36 is 1 over 9. Nine over 36 is 1 over 4. And now I'm in standard form. A is 3, B is 2. And you can process the ellipse from there and otherwise. Um, Alternative ones. So let's do this one. The book, unfortunately, does not have any examples for me. So yeah. So first thing I'm going to do is arrange my x's and y's together. And we're going to mostly follow the steps for completing the square. There's a page, they're on a page, one of the pages in your formula packet. Um, we actually do not move this 63 in this case. It's already on the side by itself. But what I am going to do is step 1.5, where I'm going to factor out this leading coefficient. So this time I'm completing the square twice on x and y. I'm factoring out this leading coefficient here, and I'm leaving room for what's called the magic numbers. Y squared plus 4y. I'm going to take half of this middle term or the b term in the trinomial. So I'm making this into a trinomial, which will factor into some binomial squared. So I take, and this is kind of the magic part, I take this number 2, I go 2 over 2, and then I square that. 2 over 2 is 1 squared, so I add a 1 in there. If I add 1 to this left side of the equation, I must add an equivalent to the right side. The thing about this 1, though, is if I distribute the 7, it's actually a 7. So I'm going to add a 7. So I'm going to actually change the color of these to the numbers that I'm adding here. Plus 1, plus 7. Those go together because 1 is multiplied by 7. Over here, I do 4 over 2 squared, or 4 over 2, and then I square that. That's 2, squared is 4. And I take that 4, and before I add it to the other side, I multiply it by -9. That's -36. Now, this is not going to add how I wanted it to. I'm going to change the number so that it adds to what I need it to. And you'll see why in a second. I'm going to change the 63 to a 92. I want it to end up being 63. I'll double check my math. Yeah. So now what I'm going to do is I'm going to take each trinomial and I'm going to factor it. And the beautiful part about it, because I made it this one, it's x plus 2 over 2, or 1 squared. Why? I screwed up again. There's another mistake. This is supposed to be a minus. Oh, that's a plus there. When I factor out -9, it makes it -4. So -4 over 2 is still -2. Squared is still +4. So it doesn't affect anything else, but it does affect this. And the beautiful part about this is whatever half this middle term is, I take this -4 over 2 there, and that is this value here, even if it's a fraction. Or I can take the square root of that. That's the beauty of following this process, because it always factors into that. Now I'll go ahead and divide by 63 on both sides. So that'll get me my 1 on my right side, which is my objective. And I chose 63 because it would actually reduce. Seven over 63 is 9. Nine over 63 is 7. And this looks like standard form of, and this is a hyperbola. Center here, -1, 2. A is 3, B is square root of 7. This one, if I go to graph it, here's my center here. Gotta go 3 each way in the x to plot my 2 vertices. And up and down square root of 7, which is and this red thing is my hyperbola. So it became super useful, and I'll do one more example here to complete the square because it made it totally graphable. Let's do an ellipse this time. Usually they list them with the y's first. Um, And you'll see why I chose that number in a second. So first thing, I gather my x's together. Now I'm going to factor out the 12 from the x squared. The x squared and the y squared will have to be leading coefficient of 1. I'll leave some room to put my magic number in. So here for the x, I'm going to take -1, divide it by 2, and square it, which is, that's 1/4. I'll multiply 1/4 times 12, and that's adding a 3, which is 12/4. I'll do the same thing with the 9. 3 over 2 squared, or with the 3 on the y, that's 9/4 plus 81/4. And this is 144 here. That's kind of nice. It just adds up to that. Factoring this, x squared minus 1x plus 1/4 is going to factor into x minus 1/2. Again, it's always take this b value, divide it by 2, and put it in down there. I think that was unclear what I was meaning. But you take the -1, whatever that b is, divide it by 2, and it goes in there, as that becomes your second number in your binomial. The key, though, again, x squared and y squared have to have a coefficient of 1 for this to work. Y plus, again, take the 3, which is my middle term, over 2. Finally, divide by 144 on each side. And I end up with an ellipse with, and a is always the larger one, so a of 4, b of square root of 12, centered at 1/2, -3/2. I'm just going to state the a and the b here. A is always the larger one, and underneath, remember, is a squared and b squared. So there you have completing the square to put these conic sections into standard form.